Question 4. A. Complete the table below and give the name for this compound A, B, C, D. Structural formula of A is given. So from here we know that this is built 1 in. First carbon, second carbon, third, and the last carbon. So the double bond is between the first and second, so that's why it's built 1 in. The 1 means the position of the double bond. B is the, this is, let's say this is first carbon, second, third, fourth. This one is built 2 in. From here we know that the C now with 2 different groups, H and methyl, H and methyl. So these 2 carbon, they have different groups. Therefore, it can form the cis-trans isomer. The CH3, which is the larger group, they are on the same side. So we call cis. Therefore, the name for the B is cis, built 2 in. For the compound C, the 2 larger group, they are at different sides. So therefore, this we call trans, built 2 in. Whenever the groups or the larger groups, they are at different side or opposite side, so we call trans. This isomer is trans isomer. So the full name is trans built 2 in. For D is very easy. So it's 2-methyl prop 1 in. 1, 2, 3. Another CH3 bonded to this carbon. So it's 2-methyl prop 1 in. Explain what it means by stereoisomerism. To explain or define this, you must mention what is the similarities or what is the same thing. So the molecules with the same molecular and structural formula, just like the cis and the trans built 2 in, they have the same molecular and structural formula, exactly the same, but the difference is how they arrange the group. So with different arrangement of atom in space. Space means how they oriented, whether it's same side or different side. So this will make the difference. Means this will give the cis or trans isomer. And this one also can use for the optical isomerism. Part B. W is an alkene with formula C4H8. It reacts with HBr, form 2 possible carbocation ion, which is this and this. From here, roughly we can predict what is a compound. The compound is A. Means the identity of the W most likely is A. Why? Because in this carbocation ion you can see ethyl group. Among this compound A, B, C, D, the B, C, D actually no ethyl in there. No ethyl. Just A has ethyl group here. That's why we are quite sure the compound W is the A actually. So therefore you just put A. And this is the reaction when the HBr reacts with the but 1 in. The hydrogen can add to this carbon or this carbon, then it will form different products. According to the Markovnikov rules, this hydrogen most likely will bond to this carbon first, because this carbon, don't point the arrow like just now. Okay, the arrow must be from the double bond point to the hydrogen, and therefore the CH bond will form new bonding, right? So the mechanism is you must put the dipoles on hydrogen, partial positive on hydrogen, partial negative on bromine. After that, draw an arrow from the CC double bond point to the hydrogen, and you have to draw another arrow, okay, from the HBr bond, and point to bromine, like this. Okay, as I told you just now, in order to form the major product, the H will form new bonding with this carbon, because this carbon with more hydrogen. Okay, then it will form this carbocation. So this carbocation, we know that it has two alkyl group. So it's a secondary carbocation, is more stable than primary. Why? Where is the primary? If let's say this hydrogen now form bonding with this carbon, then it will form this carbocation. So means this carbon is positive already. So this carbocation is primary. Primary is less stable. So the major product is always will form from the more stable carbocation. So since this carbocation is more stable, it will going to form more, and it will produce more products. So it will form these products. This is a major product. Okay, draw the skeleton formula of the major organic product when HBr reacts with W, like just now. Okay, this is the major product that I told you just now. Draw the skeleton formula. Very easy. How many carbon? 1, 2, 3, 4. So first you need to draw the carbon chain. 4 carbon, you just draw like this. 1, 2, 3, 4. 1, 2, 3, 4. And the bromine located on second carbon, just draw 1, bonding, put Br. Done. Okay, so after this, just explain why major products form. Very easy, because the 2-bromobutane, this compound is formed from this secondary carbocation, which is more stable. Why is more stable? Because the 2 alkyl group, again, because the 2 alkyl group here has the effects we call positive inductive effect. It will push its electron to the positive side, and this positive side is getting lesser, so we say that it's more stable. Okay, it's due to positive inductive effect of the 2 alkyl groups. Okay, part C. A sample of propane 1-ol reacts with concentrated H2SO4 to form propene. Identify the role of concentrated H2SO4. Of course, is dehydrating agent. Okay, part D. Alcohol Y reacts completely when warm with acidified dichromate ion to form Z. Z is distilled from the reaction mixture as soon as it's made. Tollens reagent added to Z, silver mirror form. We know that Z, it must be aldehyde. So how to form or how to get aldehyde from the alcohol oxidation? We must do distillation. So this is the distillation setup. Okay, this is a condenser. Okay, let's say now we have a reaction mixture, alcohol with the oxidizing agent, and after the alcohol being oxidized, it will form aldehyde. And this aldehyde, because it has lower boiling point, it will go up. It will go up and it will go through this, and it will condense and being collected here. So this we call distillation, means the lower boiling point product will come out from the mixture and being collected first. Okay, this we call distillation. Is to prevent the aldehyde drop back to the reaction mixture and further oxidize. So the distillation is used to prevent further oxidation of the aldehyde. Okay. So part 1, name the type of reactions when Y reacts to form Z. Of course, is oxidation. Identify the functional group present in the Z. So it's aldehyde. But nowadays, for the latest syllabus, okay, 2022 to 2024, the functional group for the ketone aldehyde, they are carbonyl group. Carboxylic acid is the carboxyl. Okay, that's all for this question. Thank you.